the last one was a little maybe unclear. Okay, but my function was n when n minus 1 over 2. Okay, I want to be able to say, is this a member of theta n squared? Okay, so we're essentially asking that question. Okay, in the back of my mind, when I'm saying that, I have this notion that I have a upper bound and a lower bound, and I want to be able to show that my kind of algorithm's curve always fits in between these. And again, we have this idea that for small values, we don't care, but from n0 and above to infinity, this should hold true. Okay, so that's what we're trying to do. And then, remember the color I'm using, this will be C1. For this function, my function is t of n, and then the blue one is C2. Okay. So, to work these things out, well, to work out what is a good constant for C1, so if I multiply this out, so n upon n minus 1 is n squared minus n, and they're both over 2. Okay, and I want to show that this is less than or equal to so of the references n squared. Okay, so this is my constant. So one of the things that's maybe hopefully obvious is, well, this is half n squared. Okay, so minus n over 2. So basically any value half n squared will satisfy this. So what we can say is, well, if C1 is half n squared, that's always going to be bigger than this side. Okay, so then we can say, well, that's not a bad place to start for C1. Okay, for C2, and again, it's the same function. We'll just write it this way because it's easier to see, over 2, and it is equal or greater to, so C2n squared. So we just need to solve this. So basically, this will always, let's see, let's take an example. So if we say n is equal to 1, we get half over, we get half minus a half, which is nothing. And yeah, we get n squared, which is 1. Okay, so again, this side is smaller. Okay, so we need to find a point at which this is bigger. Okay, so whenever n is 2, n squared will be 4 divided by 2 is 2, minus 2 over 2 is 1, gives us 1. Okay, and n squared is 4 over here. Okay, so for n equals 2, this gave me 1. N squared over here is 4. So to get this to be equal or greater than, what do I need to multiply 4 by to get to be equal or greater than? Well, if it's multiplied by a quarter, that becomes 1. So why not say, yeah, quarter n squared will always satisfy that. Okay, and then for n, in this case, I don't think n matters. You can just start at 1 and this holds true. So a proposition here is that could be 1, but it didn't work here. We had to increase n to 2. So C2 was, we're happy with that being a quarter. And this, the problem size had to be 2 before it started to work. But that will work here as well. Okay, so we basically arrive at the constants for these two functions here and here. Okay, and the really powerful thing is here, it doesn't matter how much this grows, that will always hold true. You can keep increasing n or asking Wolfram Alpha to do it for you, but eventually you'll run out of time and patience. Okay.